Okay, today we're going to start working on equations, and we're going to talk about writing and solving one-step equations. We're also going to talk about the properties of equality to produce those equivalent equations. And we're going to be using addition, subtraction, multiplication, and division to solve those. And then in the end, we'll look at some real-life problems where we can use equations to solve those. One thing I just want to mention are inverse operations before we start. Inverse operations are important when we're solving equations. So like addition and subtraction are inverse operations of each other. They are what we say undo each other. They're opposites. If I add 2 and then subtract 2, they undo each other and cancel out to 0. Multiplication and division are another set of inverse operations. Again, they cancel each other out to 0. Square and square root are another set. They undo each other. So you'll hear me say that in this lesson. What's the inverse operation? Again, we're only going to be working with addition, subtraction, and then multiplication and division today. Just to review some properties that we've worked with. The addition property of equality. This says that we can adding the same number to each side of an equation produces equivalent equations. And equivalent just means equal. So for example, if I had, let me just do something easy here. If I have 7 equals 7, that's an equation. They are equal to each other. If I add 2 to this side and I add 2 to this side, now they are still equivalent. So it keeps it in balance. This also works with variables. Let's say I had A equals B. If I were to add C to both sides, now these are different variables, they're not like terms, I would just end up with A plus C equals B plus C. However, since they're adding the same amount to both sides, they are equivalent. All right. And the same thing goes for subtracting. Subtracting the same amount the same number from each side of an equation produces equivalent equations. So again, if I had that 7 and 7, And this time I subtract 2 from both sides, I end up with 5 equals 5. And then we can do the same thing with our variables. If I had that A equals B, and let's say subtract C now instead from both sides, I would end up with A minus C equals B minus C. And that would just say, that's just stating that they're still equivalent. I would be taking the same amount away from both sides. All right, so we are gonna apply these properties and our inverse operations as we start solving equations using addition and subtraction. We're gonna start with. Our goal when we're solving equations is we always wanna isolate the variable. So you'll hear me say that isolate means get the variable by itself. I want to know, what does that variable equal? So we're starting here. I have x minus 7 equals a negative 6. So what number can go in place here so that when I subtract 7, I get negative 6? Okay, I want to isolate the variable. And that means I want just x left on this side. Well, right now, there is a subtracting 7 or a negative 7. So I want to cancel that out here on this side so that I will be left with my variable. I will isolate the variable. Well, to cancel a subtract 7, I can use that inverse operation to cancel that out. Adding 7 would cancel it. However, I have to keep my equation in balance and use that addition property of equality. Whatever I do on one side, I have to do to the other. I also find it helpful to maybe draw this line. Your equal sign is like a fence. So whatever I did on this side of it, I have to also do over here. I have to add 7 on that side as well. All right, and so those are going to cancel each other. Negative 7 plus 7 is 0. I'm only left with x on this side. I'm going to bring that down, my equal sign, and then I can add this up. I'm combining these together over here. Negative 6 plus 7 leaves me with 1. And so that would be solved. What I always like about equations too is that now I can check to see. We can check it. Does that work? I'm going to plug what I came up with for x back in here. 1 minus 7 equals negative 6. Yep, that works. 1 minus 7 is negative 6. So that checks. All right, let's take a look at this one. 1 equals a w plus 6. Here's our fence again. And now my variable's on the other side. That's okay. I want to isolate that variable, get it by itself. However, on this side right now, I have this plus 6. And I want to have just w here. So to cancel out this adding 6, our inverse operation would be subtract 6 to cancel it. Whatever I do to one side, I have to do to this other side. So I want to subtract 6 over here. Okay, I did that, so those will cancel, and I now have just my variable on this side. There's my equal sign. And now I can go ahead and figure that out. 1 and a negative 6, or 1 minus 6, would leave me with negative 5. And that would be my solution, my answer. We can check it by plugging in negative 1 here. So the negative 5 in for w. So let's see, 1 equals negative 5 plus 6. So I'm recopying that original equation, but replacing my answer for w and seeing, does it work? Negative 5 plus 6 is a 1, yeah? So that works, that checks. All right, Even with variables, we can do the same thing. I want to isolate my variable. However, on this side, that means I want just y on this side by itself. So whatever else is here, I need to cancel it out using inverse operations. So I would want to subtract 3.4. Whatever I do to one side, I have to do to the other. So I want to subtract 3.4 on the other side. Okay, those cancel. And so on this side, I'm left with just my y, my equal sign. And then we have 3.5 minus 3.4. Now remember, when you are subtracting, I got 3.4 and 0.5. I want to line those up. I'm subtracting because they're different signs. And so, oops, sorry, that's a 3. I was thinking ahead. So we have to borrow, whoops, sorry. So that was 2 and 0.9. And the negative was on the 3.4, so I have more negatives. My answer would be negative. All right. This is also a section, I don't mind if you guys use calculators. So if you want to double check your work, use the calculator to do that. So you're not spending all your time. Then we can double check. Negative 2.9 plus 3.4. Does it come out to 0.5? Yes, it does. Okay, you guys can pause the video, try these on your own, and then I'm gonna go through these a little bit quicker so that you can see how you did. So solve it and then check your solution. All right, here we go. We want to isolate the variable. So I want to cancel this out. Right now it's adding 2 on this side, and I want b, the only thing over here. So I want to subtract 2 from this side. Whatever I do to one side, we need to do to the other. So those will cancel, and I'll be left with b. And again, we're combining these together. -5 and a -2 leaves me with -7. If I want to double check, -7 plus 2 does equal -5. So I know that that works. I did come up with my correct solution there. This one, k, is our variables on this side, but I want to cancel whatever is on the side with a variable because I want to get that by itself. So I'm going to subtract 3 and subtract 3 on the other side. Those cancel, and I get k equals, combining those together, so that gives us -6. Some students also really like their variable on the other side. You can turn it around and say k equals -6. That's okay as well. Those are saying the same thing. Check it. Recopy that top equation, but instead of k, we'll put in -6 and see, does that work? -6 plus 3 is -3, so that does work. All right, and then on this one, even with our fractions, if I want to isolate the variable, I would have to add 1/4 on this side, and then I would want to add 1/4 on the other side. Those will cancel, and I get t equals a -3. We have common denominators, so we're good. I just have to add up my numerators. -3 plus 1 would be -2. Denominator stays the same. That I could also say is a -1/2. So t can be -2/4 or -1/2. And then just double check. If I put that back in here, -2/4 minus 1/4 does give me -3/4, so that checks. Okay, next we're gonna do equations with multiplying and dividing. So again, we're talking about those inverse operations. Multiplication and division undo each other. When we apply the multiplication property of equality, that states that we can multiply both sides of an equation by the same number. And that will produce equivalent equations. So using those variables, like if I had an equation that said A equals B, this property says if I multiplied both sides by C, it would be okay to say that A times C is still equal to B times C, as long as they're both multiplied by the same amount. They would stay equal. And then same thing for the division property of equality, dividing both sides of an equation by the same number. Again, is going to produce equivalent equations. Equivalent. Hang on. And so that one might look like, again, if we had our A equals B, we could also just divide them by that same amount. Okay, so let's do a couple examples. And again, we want to focus on isolating the variable. And so right now, look at what's happening with the variable, because the variable is what I want to get by itself. And it's being multiplied by 4 right now. So to undo that, I need to use the inverse operation. What cancels out multiplying by 4 would be dividing by 4. And then again, if this is our fence, our equal sign, whatever I did to one side, I have to do to the other. That's back up here with our division property of equality. So that keeps your equation in balance. So we're also going to divide this side by the same number, 4. 4 divided by 4 is 1. So that's really 1x, which I can just bring down as x, our equal sign, and then 32 divided by 4. And so that gives us our answer there. So on this one, we wanted to divide both sides by 4. Let's take a look how this one's set up. M divided by 9. So our variable is already being divided by 9. That inverse operation of dividing by 9 would be multiplying by 9. So I'm going to multiply this side by 9. And whatever I do to one side, I have to do to the other. This is really, if I want to, because this kind of looks like a fraction. If I think of this as a fraction, I can put it over 1. And what happens is the 9s actually cross cancel. Again, this is like a 1 times m, or 1m, which I can just write as 1, equals 54. All right. We'll get into some problems here with negatives. Again, I want to cancel whatever is by the variable, I want to be left with just the variable on this side. So multiplying by a negative 4.3, what is our inverse operation that would cancel it? Or in this case, we're canceling it out to 1. I have to divide by the exact same amount. And a negative divided by a negative would turn positive, and that's what I want, a positive 1 right here. So in this case, I do want to divide by the negative, and I want to divide by the exact same thing on the other side, by negative 4.3. So again, these cancel to 1. 1g is the same as g, and if we divide this out, that would give us a negative 6. And you can always double check too. Negative 4.3 times negative 6. A negative times a negative does turn positive, and we would get 25.8. All right, here, on this one, I'm gonna think of this, I'm gonna apply this negative sign here down to the 8. So I wanna think of this more as a over negative 8, a divided by negative 8 equals 7. And so a is being divided by negative 8. My inverse operation that would cancel dividing by negative 8 would be to multiply by that same amount. And I want to multiply by the negative as well. So I'm going to multiply by negative 8. And I can also think of that as over 1. Whatever I did to one side, I'm going to do to the other. I want to multiply this side by negative 8, or negative 8 over 1 as well. And again, what happens, these cross cancel. Negative times a negative will turn positive. That's what we want, so that we have 1 here, 1a, which is just a, and multiply 7 times your negative 56, or negative 8 gives us negative 56. All right, this one, we have, looks like a fraction. One of the ways, so this was didn't really mention it with our inverse operations, but one way to cancel out a fraction when you're multiplying is that we can use the reciprocal. So on this one, we want to actually cancel the negative 3/4 by multiplying by the reciprocal. And that is where we flip or change the numerator and the denominator. And so I'm going to multiply by negative 4/3 on this side. Let me mark that up over here, actually. So I'm going to multiply by negative 4/3 on this side. Reciprocal, so we multiplied by negative 4/3 on this side. We have to multiply by negative 4/3 on this side. Since we're multiplying by a fraction, we can also think of this one as a fraction by putting it over 1. Negative times negative will turn positive. And again, all of these are going to cross cancel. The 4's cross cancel, the 3's cross cancel, leaving us here with positive 1n. So I can just bring down n. When we're multiplying with fractions, we multiply our numerators. Negative 2 times negative 4 is a positive 8. Multiply the denominators. 1 times 3 is 3. And we can just leave this one an improper fraction. This one looks a little crazy here. We got, that's the symbol pi times our variable x equals 3 pi. So again, I'm going to that variable. I want to isolate the variable, cancel anything that's on the side with it. Well, right now it's pi times x, so the inverse operation that would cancel out that multiplying by pi would be divide by pi. Whatever I do to one side, do to the other. And just like if I had a number here, 2 divided by 2, they're going to cancel to 1. pi divided by pi. Pi, by the way, is that 3.14159, that irrational number that we'll be learning about when we do our unit on circles. But for now, those numbers would cancel to 1 and leaving us with just 1x. So I'll bring down x. And again, on this side, we're dividing and happen to be pi over here as well. Those are going to cancel and leaving us with just 3. So on that one, x equals 3. Okay, here's some for you to try on your own, and then I will go through them. So if you want to pause the video, and then you can check it together. All right, this one here, y divided by 4 equals -7. You wanted to multiply both sides by 4 so that these cross cancel, and you should have got y equals a -28. This one here, if we think of it just I'm going to rewrite it for you just in a little different way. -2/3 z equals 6. So that is a fraction there, and we can use that reciprocal to cancel. So I can multiply by 3 over -2. And then I want to multiply by that same amount on the other side. So the 3's will cancel, cross cancel, -2's cross cancel, leaving us with just z equals, and I can make that 6 a fraction by putting it over 1. So 6 times 3, and then 1 times -2. Now this one is improper, however, I can simplify it a little more. 18 divided by -2. So I can say z is equal to -9. All right, this one, decimal, again being multiplied by w. So to cancel it, I will use that inverse operation, divide. I want to divide by that decimal, 9/100ths, and then on this side I'm also going to divide by 9/100ths. That will cancel. Uh-oh, I got a dog walking by here, sorry. And if I divide these decimals out, that comes out to 20. All right, number 7. 6 times pi equals pi times x. Again, I'm going to go to where the variable is, and I want to cancel that multiplication by pi. My inverse to do that, or inverse operation, will be to divide by pi, because I want to cancel that. I want to be left with just x on one side. I'm going to have to divide this side by pi as well. So that cancels to 1, this cancels to 1, and I'll be left with 6 equals x, or if you rewrote it, that's the exact same thing as well. All right, very good. Let me enlarge that. This one is a little multiple choice here. What value of k makes the equation k plus 4 divided by 2/10 equal to 5 true? So we can say k, and if I do this part of the problem here, 4 divided by 2/10 would be 20. Equals 5. And now I just have this one-step equation. My variable has adding 20 to it. So to cancel that out, I can subtract 20, and I would want to subtract 20 on the other side. Those cancel, and I have k, 5, and a -20. Give me -15. So in this case, A would be our correct answer. A couple more. So these involve just a little, maybe combining some things on the other side here by the variable before we start solving and doing inverse operations. So you want to try to combine any constants that you can. So for this part, on this side with the variable, I can go ahead and do this and then rewrite what I have. It would be P -8 divided by 1/2. Actually, dividing by 1/2 is the same as multiplying by 2. So -8 times 2 would be -16 equals -3. And again, I want to isolate the variable. I want to be left with just P. So to cancel out subtracting by 16, I can add 16. And I need to do that to both sides. And -3 plus 16 leaves us with 13. All right, and again, I just want to make sure everything's simplified before you start doing your inverse operations. So this absolute value of -10 is actually 10. Remember that distance from 0. So this problem is really Q plus 10 equals 2. So I would want to do my inverse operation, subtract 10 from both sides. So Q would be equal to a -8. All right, a few word problems. The temperature in a crater on Mars is at 0 degrees Celsius at 1 p.m. The temperature decreases 8 degrees Celsius every hour. When will the temperature be -50 degrees Celsius? So this is how we would want to set it up if we're thinking about it verbally. The change in the temperature equals the hourly change times the time, multiplied by time. The variable we're going to use, we can say T is going to be our time. And that's what we're going to be finding out. What will be the time when the temperature is -50 degrees Celsius? So the equation, our change in temperature would be -50. Our hourly change, here's our every hour. So every hour it's going down 8. That's important. -8 multiplied by our time, and we said that is our variable. So we're going to solve this. Right now it's being multiplied, so I would want to divide both sides by -8. So -50 divided by -8 gives me 6.25. So that's our time. And if we think about that in time, we're really talking 6 hours and a quarter. So if you think of a clock going quarter of the way, that's at 15 minutes. And this would be after our 1 o'clock, because we were already had our temperature at 1 o'clock here. So the temperature will be -50, because it went, our change in our temperature went from 0 to -50. So we can say this would be after 1 o'clock. So that would make it 7:15. So temperature will be -50 degrees Celsius at 7:15 p.m.